that is going to be part of your project. So you definitely want to be able to create these yourself because you will have to do that for your project. We're going to start out, this is called a box and whisker plot. It is because it's made up of, do we see, it's like a box right here. And then the box has like some little whiskers off to the side. That's why it's called a box and whisker plot. So I'm going to tell you all the different parts of this box and whisker plot. So imagine you have a set of data. Like you remember on Friday, we were talking about like bowling scores or something like that, right? You've got a set of numbers. We're going to plot those numbers on a number line. I'm just going to make up some numbers that don't really mean anything. We're going to do a little number line here. Just real quick. Something like that. Okay. Your box and whisker plot is on a number line. So let's say, I don't even know what this could be. Something. We take our data, however many data points we have. We're going to order them from least to greatest. One of the things that we talked about, and I'm going to go out of order a little bit here. One of the things that we talked about on Friday was how to find the median. Okay, this right here is the median. The median is this center line in our box. Okay, that is the middle number in our set of data. So whatever is exactly in the middle. Let's say I have 9 scores, the 5th score that is exactly in the middle would be my median. We also have the lowest value. Oops. Let me do a different color. The lowest value is the end of my whisker on the low end, and my highest value is the end of the whisker on my upper end. So far we have the lowest value, the exact middle value, and the highest value. Everybody okay with that? Then, if I think about my box and whisker plot, I have now split my data into halves. So I have the lower 50% over here, and I have the upper 50% over here. If I look at the lower 50% and I split that in half again, right here, this is the median of the lower 50%. We call it the first quartile. So the lower 50%, we're going to split it in half again to get a first quartile. We do the same thing for the upper half. We take that upper 50%, we find the median of that upper 50%, and we call that the third quartile. Okay, now essentially, I've cut my data into 4 pieces. Each piece represents 25% of my total data. That's essentially the box and whisker plot. Each section of the box and whisker plot represents 25% of data. Any questions on that? That's kind of like the basics here. We also might have outliers. These are things in our data that kind of skew our data. Do you remember how we had like one bowler who was a lot better than the rest of the bowlers? That person was an outlier. In order to calculate whether something is or is not an outlier, we first have to calculate something called the interquartile range. Interquartile range, very simple. You take the third quartile and subtract the first quartile. So we would take this number right here and subtract this number right here. So for this case, those numbers that I put on there, to find the interquartile range, I would do 8 minus 5, something like that. Once we have the interquartile range, to find an outlier, we have a formula. We have the formula. I'm going to zoom in here. 1.5 times the interquartile range. And to find if something is an outlier, I'm going to explain a little bit later on in this packet, but just for right now, write it down. To find if something is an outlier, we take this number. I'm going to call this number, I don't know, let's call it O for right now. To find this number, I would do the quartile 1 minus that number to find if it's an outlier, or quartile 3 plus that number to find if it's an outlier. I'm just using a silly symbol because I guess we could call it X too, whatever you want to call it. Okay, so I do my interquartile range times 1.5, and then to figure out if something is an outlier, it has to be outside these limits. And I will explain that when we get there in the next example. Any questions on any of this vocab so far? Okay, so let's look at an example. Let's look at some math quiz scores. So a bunch of students took math quizzes. They put all of their scores in order, and then we found some things. So again, let's go over some of that vocab. We have the minimum score. We have the maximum score. Right in the middle, right here where this line is, that's our median. On the ends of the boxes, here and here, those are quartile 1 and quartile 3. And then each chunk of this box and whisker plot represents 25% of the data. So the whisker on the left, 25%. The left side of the box, 25%. Right side of the box, 25%. Right side whisker, 25%. Does that make sense? Okay. So, letter A, what was the highest quiz score? I'm going to go ahead and look at for my maximum. I think this graph counts by 2, so 92, 94. This is 96. 96 was my highest quiz score. And then it asks, what percent of the students scored between an 80, here's 80, and a 96? So what percent of my box and whisker plot is inside of those limits? How many chunks do we see? See one chunk of the box, one chunk of the whiskers. Each chunk is 25%, so that's a total of 50%. Does that kind of make sense? That means 50% of the students that were scored above an 80, or between an 80 and a 96. Okay, let's keep going. How did the students' scores vary? This question is asking me to find the range. We did range on Friday. Range is where we take the largest number, or the maximum, minus the smallest number, the minimum. So our largest number was a 96. The minimum value here looks like it's about 63. 96 minus 63, our range of scores is 33 points. Interquartile range, that's one of our vocab words. The interquartile range, we take quartile 3 minus quartile 1. So let's figure out what those numbers are. Quartile 3 looks like it's about 83 over here, I would say. Quartile 1 is 70. So the IQR is 83 minus 70. What percentage of quiz scores were at most an 83? So let me get rid of some of my numbers here. What percent were at most an 83? At most means no bigger than 83. What percent of my data falls underneath an 83? Here's 83 right here. How many sections, Max? Yeah, 75%. There's 3 sections of my box and whisker plot underneath that. So that's 75%. And then last one for this page, the bottom 50% is between what scores? So that's everything lower than my median. The bottom 50% goes from 63 to 80. Any questions? Okay, flip it over. All right. Now we are going to do 2 box and whisker plots in one. I would really appreciate your participation in this part. I have on top is a box and whisker plot for the weight of these Asiatic black bears. And on the bottom is a box and whisker for the weight of pandas. So for letter A, what percentage of Asiatic black bears, the graph on the top, weigh more than 225 pounds? Here's 225 right here. What percent weighs more than that? Jacob. 75%. There's 3 sections. 1, 2, 3 sections of my box and whisker plot. So that's 75%. Interquartile range for pandas. Our formula for the interquartile range is quartile 3 minus quartile 1. So I'm going to find quartile 3 and quartile 1. They are the edges of the box, by the way. So quartile 3 is 250. Quartile 1 is 200. So my interquartile range is 50. Letter C, what type of bear has a higher percentage of bears that weigh 250 pounds? Here's 250 pounds. Neither one. 25% of black bears weigh more than this. 25% of pandas weigh more than this. They are the same. Both are 25%. Oops. Good. That was a tricky one. Okay. Half of pandas weigh at least how much? Halfway is our median. Remember, median means middle. So, I don't know, let's call that, well, I would say 210. 240 would be over here somewhere. You want to look at the pandas, not the black bears. So this is, I would say, about 210. Oh, that's not what I wanted to do. Okay. What's the lowest weight of a black bear? 200, right here, minimum. What's the highest weight of a panda? 275, right there. What's the range of black bear's weight? That's where we take the largest number minus the smallest number. The largest is 400, the smallest is 200, so we're doing 400 minus 200. The range is 200. Okay, now this one I want you to star. Now we're going to talk outliers. We kind of talked about it in the definition section. Let's really get into it. This says, if a panda weighed 150 pounds, would that be considered an outlier for the above plot? So we're looking strictly at pandas. Okay, so the bottom one. I'm going to scroll back up in our notes so we can see our notes about outliers. We need to first find the interquartile range, which we did in part B. So we're going to use that number. Our interquartile range for pandas was 250 minus 200. Let's see if I can get this over here. Oh gosh. 250 minus 200 was 50. So our interquartile range that we're going to use in this problem is 50. Everybody cool with that? Now, to find an outlier, I'm going to multiply this number by 1.5, which gives me, anybody? 75, good. And now 75 is going to act as like kind of a magic number for us. I'm going to zoom out to my graph really quickly. Let's see if we can see this. That basically means from the box is like the middlest part of my data. It's the middle 50%. I cannot go more than 75 this way or more than 75 this way. If I do, then it's considered an outlier. So to find the outliers, I'm going to take quartile 1, which is this guy right here, and subtract 75. And I'm going to take quartile 3 and add 75. And that'll tell me like the limits that I need to be in between. So let's do that right now. Quartile 1 for my black bears was, what did I say it was? 200. Oh gosh. Okay, so quartile 1 is 200. That's the edge of the box. I'm going to subtract 75. That means I cannot go lower than 125 or it's an outlier. For quartile 3, I'll do 250 plus 75 to get 325. So anything 325 and above is an outlier. So to answer my question, if a panda weighed 150 pounds, would we consider that an outlier? No. Does that kind of make sense? Any questions on that? This, again, I would star this one because that is definitely one of the harder ones on this page. All right, 2 more. What percent of Asiatic black bears weigh between 200 and 250 pounds? Do I need to go back to the graph? Here's 200. Here's 250. Did I do that right? Was that what the question was asking me? Oh, sorry, not 250, 240. Here's 240. What percentage is in between those? How many sections of my graph am I looking at? 2 sections. Each section is 25%, so that's 50% of the data. And then which type of bear has a higher percentage of bears that weigh more than 200 pounds? The black bears. Because what percent of black bears weigh more than 200 pounds? 100%. Any questions on this?